The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
So question number 17 asks us to determine which of the following samples is the heaviest. So it gives us 4 different samples and it tells us how many atoms each one has. So first it tells us we have 1.1 times 10 to the 23rd atoms of gold. It then goes on to say we have 2.82 times 10 to the 22 atoms helium. 1.8 times 10 to the 23 atoms of lead, and 7.9 times 10 to the 21 atoms of uranium. So, it wants us to know which one weighs the most. Well, if we're not from a chemistry perspective, we don't know just by looking at how many atoms there are for how heavy something is. But what we can do is we can go through and find the number of moles that something has, and then once we know moles, we can use the atomic weights to find out how many grams of a substance we actually have. So the first thing that should come to your mind when you do a question like this is, how can I relate atoms to moles? Well, we know that there's Avogadro's number, and that is equal to 6.02 times 10 to the 23. So what I'm going to do is I'm going to take each of these numbers and I'm going to divide it into Avogadro's number so we can find out how many moles we actually have. So 1.1 times 10 to the 23 divided by 6.02 times 10 to the 23. That equals 0.1827 moles of gold. And we'll keep doing that. 2.82 times 10 to the 22nd divided by 6.02 times 10 to the 23rd. 0.0468 moles of gold. .299 moles of lead. And 0.01312 moles of uranium. So, now we know how many moles we have. So, from the beginning, you can get a basic understanding that the larger the number is with the exponent here, times 10 to the 23rd, times 10 to the 24th, the greater the amount of moles you're going to have. And the smaller it is, the less moles. So 10 to the 21st, the uranium is going to have less moles than 10 to the 23rd of lead. But you can't just go based on that because every single element has a unique atomic mass. And if we had 5 moles of helium as opposed to X amount of uranium, because the atomic mass for uranium is so high, we wouldn't need as many moles to find the weights. So what I did is I went to my periodic table and I wrote down all of the atomic masses for gold, helium, lead, and uranium. So for gold, it's 196.97 grams per mole, 4.00 grams per mole helium, 207.2 grams per mole of lead, and 238.02 grams per mole of uranium. So now what we have to do is we have to cross out the moles to get grams. So what we're going to do is we're going to take 0.1827 moles times 196.97 grams per mole. Moles cross out, and that leaves us units in grams. So when we do that, we get 35.99 grams of gold. So let's go ahead and do 4.00 grams per mole times 0.0468 moles. .1872 grams of helium. So we already know that gold has more grams than helium, so we can get rid of helium as an answer choice. 0.299 times 207.2 grams per mole gives us 61.95 grams of lead. So we know that the lead weighs more than the gold. So the last one we do is uranium, and we do 238.02 grams per mole times 0.01312 moles. And we get 3.12 grams of uranium. So we can see by our answer choices that the lead weighs the most with 61.95 grams. So our answer choice should be answer choice number 3, the lead sample. Now, just a little caveat when you're doing something like that. If somehow we got the same amount of moles for uranium, so if it was 1.8 times 10 to the 23rd atoms for lead and 1.8 times 10 to the 23rd atoms for uranium, we would have the same amount of moles. Except the atomic mass units are much larger at 238 as opposed to 207. So if we had the same amount of atoms for lead and uranium, we would actually have a greater number of grams for uranium. That's just something to think about if you see that on an exam. So the answer again for question number 17 is answer choice 3.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.